Hey guys, welcome to lab. This is our first lab that we're going to do. It's called measurement and error. The objective of this lab is to measure the mass and linear dimensions of an iron bar to calculate the density of iron and a plastic cylinder. Okay, so the first thing that you're going to be seeing is the order in which we present our labs, and which is the order you're going to write your labs up. Okay, so because when you write your lab up and you use Docs or Word or PDF, when you send it in, it all has to be in order. I don't want to be jumping around looking for stuff. If I am, I'm going to take off points. Okay. So the first thing what we had is we have a piece of iron. Okay. We measured the length, the width, and the height using three different items: a ruler, a vernier caliper, and a micrometer. Okay, each one's more and more accurate. Okay, it has more decimal points, it's more accurate. Okay, and what you're going to notice on these labs is we took pictures of everything that we did, and they're included. So as you scroll through this PDF, you'll see all the different pictures. You don't have to zoom in to read the numbers, but that's how you get your data. Okay, so in the first one, we measured the three sides of the iron bar. Okay, and then the next part, we had a cylinder. There should be two lines here, but it wasn't cooperating. But so it's a little cylinder, and we measured the diameter and we measured the height of it. Okay, so when we took the diameter, we took half of that to get the radius. Okay, the volume of the cylinder is pi r cubed h. Okay, I'm sorry, r squared h, not r cubed. And the density of the iron bar is 7.874 grams per cubic centimeter. So the procedures: we obtained the iron bar, ruler, micrometer, and a vernier caliper. Measured the mass using a balance. And that was in grams. We measured the length using a ruler, the width using the vernier caliper, and the height using a micrometer. And then we calculated the density by doing mass divided by length times width times height. Okay, because density is mass over volume. We did all that. Then the next thing we did is we took a plastic cylinder, and for our plastic cylinder, we measured the mass, the height, and the diameter. We cut the diameter in half to get a radius, and then we calculated the density using m equals pi r squared h. Okay. As far as error analysis go, you have to do an LC and an AE. LC is least count. The least count is how precise that item is measured. For instance, the mass balance measures up to 0.1 grams. Okay, so I can either, if it's 32.4 grams, I can either measure 32.4 or 32.5. I can't estimate anywhere in the middle there. It's either this or it's this. Okay, so it's 0.1 grams is the least count. Your ruler, if you look at it, the least count would be 1 millimeter. So that would be 0.1 centimeters. Okay, so you're going to have to do that for each device. Okay. AE stands for absolute error. Absolute error is half of whatever the least count is. Okay, so half of 0.1 is 0.05. All right. Error propagation, you're going to have to do error propagation for the iron bar only. In order to do that, you need to refer back. I said make sure you read these documents before you do lab one. You'll have to go back and it'll show you how to do error propagation. I actually did an error propagation for an iron bar a couple years ago, and I just wrote it by hand, and that's what was on it. Okay. All right. So then here is the first picture is the metal bar's mass. So you zoom in and you'd read what it is. Okay. Metal bar's length, notice it starts at 5 centimeters and goes to that area over there, which looks like about 12.6. So you'd subtract those two numbers to find the length. Metal bar's width, we used a ruler again. That's fine. Do the same thing for that. And then the thickness, we use the vernier caliper. So apparently in this lab, we don't have the picture for the micrometer, but it's okay. We'll just ignore that part. Okay. Now, if you notice, the measurements on the vernier caliper are in millimeters. So 6.29 millimeters would be what in centimeters? It'd be 0.629 centimeters, right? So you want to make sure you're moving it correctly. All right. Here's our plastic cylinder. There's the mass. Here's the plastic cylinder's length. All right. And then there's the micrometer there. That's going to give us our diameter. And if you look at that, that says 15.935 millimeters. Okay. So you'd have to adjust that. All right. So if you're looking at that, it has 1, 2, 3 decimal points, okay, in millimeters. So that would be 4 decimal points in centimeters, right? So the least count for that device would be 0.0001. Okay. All right. All right. So that is the data, and then you just have to write it up. Okay. Good luck. If you have questions, shoot me an email. If you need me to call you or WebEx you, I'll try to set up a time when we both can get together. All right? Thank you very much. Have a great day.